Hello everyone, I am Prakhya Jain, Assistant Professor, Department of Mechanical Engineering, HIT Mangalore. Today I am going to discuss about dimensional analysis, that is Module 4, Class 3. A syllabus for today's class includes methods of dimensional analysis, Rayleigh's method and related problems. So first let's go for methods of dimensional analysis. So if the number of variable involved in a physical phenomenon are known, then the relation among the variables can be determined by the following two methods, Rayleigh method and Buckingham's pi theorem. So variable means this is a parameter related to a problem. If those parameters are variables known in a problem, then we can establish relationship between the variables. There are two types of variable. First one is dependent variable and second one is independent variable. We can establish relationship between dependent and independent variable using methods of dimensional analysis. That is, there are two methods, Rayleigh's method and Buckingham's pi theorem. Rayleigh's method. This method is used for determining the expression for a variable which depends upon maximum 3 or 4 variables only. So this method of dimensional analysis is applicable for obtaining a relationship between independent and dependent variable. If the number of the independent variable is limited to 3 or 4 only. So this is a limitation of Rayleigh's method of dimensional analysis. It can be applied to obtain relationship between dependent and independent if the number of independent variable is limited to 3 or 4 only. So there is a limitation. So if the number of variable, that is independent variable, crosses more than 4, then it is very difficult to solve that kind of problems. So let's go for procedure involved in solving dimensional analysis using Rayleigh's method. First step, list out all the variables present in the given problem. So first we have to look into the problem and we have to list out all the variables involved in the problem and we have to classify into those variables into dependent and independent variable. Then step 2, let x is a variable which depends on x1, x2 and x3 variables. Then according to Rayleigh's method, x is a function of x1, x2 and x3 and mathematically it is written as x equal to function of x1, x2, x3. So here they are going to assume x as variable, so which depends on x1, x2, x3. That means x is a dependent variable whereas x1, x2, x3 are independent variables because x is dependent on x1, x2 and x3. Then according to Rayleigh's method, x is a function of x1, x2, x3. So we have to express dependent variable as a function of independent variable. So mathematical form is x equal to function of x1, x2, x3. So that's in step 2. Next let's go for step 3. Now write the above equation in the form x equal to k into x1 to the power a into x2 to the power b into x3 to the power c. Take it as expression 1. So we have to rewrite the expression x equal to function of x1, x2, x3 in the format x equal to k into x1 to the power a into x2 to the power b into x3 to the power c. So with exponents a, b, c and k is a constant or it is a dimensionless term. Next, let's go for step 4. The values of a, b and c are obtained by comparing the powers of fundamental dimension on both sides. First, we have to know what is fundamental dimension. As I already discussed about fundamental dimension in previous video, so there are 3 fundamental quantities or dimensions, that is m for mass, l for length and t for time. So the values of a, b, c, those the exponents can be obtained by comparing the powers of fundamental dimension on both sides. That is otherwise called as dimensional homogeneity. Dimension on both sides of the equation should be same. So based on equating dimensions of both sides, we can get values of a, b, c. So step 5, substitute the values of exponents a, b, c in equation 1 and get the required equation. So equation 1 is this one. x equal to k into x1 to the power a into x2 to the power b into x3 to the power c. So we can substitute back values of a, b, c that is obtained by using dimensional homogeneity in that expression, and we can get final expression for dependent parameter. So this is a step involved in Rayleigh's method. Let me go through once again from beginning. Step 1, we have to list all the variables in the problem, given in the problem, and then we have to classify into dependent and independent variable. Then second step, we have to express dependent variable as a function of independent variable, that is x equal to function of x1 comma x2 comma x3. Then step 3, we have to express expression x equal to f of x1 comma x2 comma x3 in the format x equal to k into x1 to the power a into x2 to the power b into x3 to the power c, and you have to take it as expression 1. Next, step 4, values of exponents a, b, c can be obtained by dimensional homogeneity, that is equating dimensions of MLT on both sides. Then step 5, substitute the values of exponents ABC in equation 1. So that is equation 1 is x equal to k into x1 to the power a, x2 to the power b into x3 to the power c. So we can get expression for dependent variable in terms of independent variables. So let's go for problem here. First problem, the time period that is represented by t, small letter t, of a pendulum depends upon the length, there's a capital letter L, of the pendulum, and acceleration due to gravity, that is small letter g. Derive the expression for time period. So here we can see a time period that is small letter t, that depends on two parameter, length and acceleration due to gravity. So we can see from this problem only that time period is a dependent parameter, whereas length and acceleration due to gravity are independent parameter. So we have to express time period in terms of L and G. So solution, time period t is a function of L and G. It is given in problem itself is a function of length of pendulum and acceleration due to gravity. So first step is here, we have to write dimensions of all the parameters involved, like dependent as well as independent. So dimension of L is, that is a length, so dimension for length is L only, and dimension for G, the unit is meter per second square, so meter is the SI unit of length, so dimension for meter becomes L, and second square per second square, so it becomes per t square, that is second square is a unit of second is a unit of time, so it becomes t to the power minus 2 when goes to numerator. So overall dimension for acceleration due to gravity becomes Lt to the power minus 2. So we have to then step 3, we have to express in the form of exponents, like x equal to k into x1 to the power a into x2 to the power b into x3 to the power c. So here in place of x we get term t, because this is the dependent parameter. So t equal to k into L to the power a into g to the power b, where k is a constant and a and b are exponents. Take it as expression 1. Then substituting the dimensions on both sides. Okay, I forgot to tell about dimension of time period. Time period is actually it's time only. So unit for SI unit for time is second. So dimension for time period becomes t. So substituting the dimension on both sides, that is t to the power 1 equal to k is a constant. It has no unit. So keep as it is, k into L to the power a into Lt to the power minus 2 to the power b. So there's a dimension for Lt to the power minus 2 is the dimension for G. So Lt to the power minus 2 to the power b. Then equating the powers of M, L and T on both sides we get. So first we have to equate. We can go in any order, like we can start with equating powers of M, then we can go to L, then we can go to T. So otherwise you can start reverse order also. Anyway, anything is possible. So let me go here. Let me start with equating power of T. So you can see the expression there. T to the power 1 equal to k into L to the power a, Lt to the power minus 2 to the power b. So left hand side equation for T, power for T is 1. So left hand side becomes 1, that is equal to, on right hand side equation, T to the power minus 2 to the power b. So power becomes minus 2b minus 2b. So 1 equal to minus 2b. We can calculate now b by rearranging the expression. Therefore b equal to minus 1 by 2. So that is obtained by equating the power of t. Now we can go for equating the power of L. So equating the power of L, we can see the expression t to the power 1 equal to k into L to the power a into L t to the power minus 2 to the power b. On left hand side there is no L term. So L to the power 0, we can consider L to the power 0. So power becomes 0 on left hand side. And right hand side, that is we have L to the power a and L to the power b. So powers are a plus b. So 0 equal to a plus b. It becomes, by equating the power of L, we get 0 equal to a plus b. But we know the value of b as minus 1 by 2. So we can get expression by rearranging a equal to minus b. So a equal to minus b, we know value of b. So a equal to minus b, that is equal to minus into minus 1 by 2. So that becomes 1 by 2. So here no need of going for equating the power of m, because you can see the expression t to the power 1 equal to k into L to the power a, L t to the power minus 2 to the power b. On both sides of the equation we don't have m term. One more thing, we have two values a and b, and two expressions are sufficient to solve that constants or two values a and b. So we need not go for equating the power of m, because there is no m term on both sides of the equation. So we got values of a and b. Now we can substitute back values of a and b in equation 1. So t equal to k into L to the power half, that is actually L to the power a. So in place of a we can substitute 1 by 2. Then g to the power b. So in place of b we can substitute minus 1 by 2. So overall expression becomes t equal to k into L to the power 1 by 2 into g to the power minus 1 by 2. That is equal to k into square root of L by g, because we can rearrange the expression t equal to k L to the power 2 g to the power minus 2 as t equal to k L to the power 1 by 2 denominator g to the power 1 by 2, because when g to the power minus 1 by 2 goes to denominator, it becomes g to the power 1 by 2. So power 1 by 2 means it is a square root. So that is so you can get expression for time period as t equal to k into square root of L by g. So or L by g to the power 1 by 2. The value of k is obtained from experiments, which is given as k equal to 2 pi. So otherwise we can keep constant as it is k. So we know here from value of k from experiments as 2 pi. So we can substitute in place of k as 2 pi, and we can get expression for time period as t equal to 2 pi into square root of L by g. So there is the expression for time period. So it's a very simple problem. First we have to classify the parameters into dependent and independent. Then we have to express in the form of exponents and some constant, that is t equal to k into L to the power a into g to the power b. Now, and we have to write dimensions on both sides of the equation for time period and for length and acceleration due to gravity. Then we should go for equating the powers of m, L and t. Here as there is no m term, so we need not go for equating the power of m. Even though if we go for equating the power of m, we are going to get 0 equal to 0. So it's of no use. So we can calculate values of a and b by equating power of t and L. Then we can substitute back in equation 1, that is t equal to k into L to the power a into g to the power b. So then we can simplify that expression, and value of k from experiments, that is equal to 2 pi, we can substitute in that expression, and we can get expression for time period as t equal to 2 pi into square root of L by g. So there's a first problem. Now let's go for a very important second problem. So find an expression for drag force on a smooth sphere of diameter d moving with the uniform velocity v in a fluid of density rho and dynamic viscosity mu. Solution: drag force is a function of, first one is diameter, second one is velocity, third one is density, and fourth one is dynamic viscosity. So it is clearly mentioned in problem. Drag force is a function of diameter, velocity, density and dynamic viscosity. That means drag force is a dependent parameter or dependent variable, whereas diameter, velocity, density and dynamic viscosity are independent variables. So first step, we have to write dimensions of all parameters including dependent and independent. So let me start with dimensions of writing the dimensions of all the parameters. Dimension of d, that's our diameter, that is always measured in meter in SI unit, so dimension is CL. Whereas velocity is rate of change of distance, that is meter per second is a unit for velocity, so dimension becomes LT to the power minus 1, because when second goes to the numerator it becomes meter into second to the power minus 1. Then dimension for density, that is mass by volume, SI unit is kg per meter cube or kg into meter to the power minus 3. So dimension becomes ml to the power minus 3. And dynamic viscosity, it has unit Newton second per meter square or Newton second meter to the power minus 2. Newton can be obtained from formula F equal to ma. Newton is a unit of force. So F equal to ma, that is Newton's second law of motion. So a force equal to mass into acceleration. So unit of force is kg meter per second square. So we can substitute kg meter per second square in place of Newton and get the dimension for dynamic viscosity. So dimension for dynamic viscosity is ml to the power minus 1 t to the power minus 1. Therefore F equal to k into d to the power a into v to the power b into rho to the power c into mu to the power d. Take it as expression 1. So expressing dependent parameter and independent parameter in the form of some constant and exponents. So where k is a constant or dimensionless term and a, b, c, d are exponents. Next, substituting the dimensions on both sides. On left hand side we have force, so dimension of force is ml t to the power minus 2, that is equal to k into diameter to the power a, dimension for diameter is L to the power a, into velocity to the power b, that is Lt to the power minus 1 to the power b, into rho to the power c, dimension for rho is ml to the power minus 3 to the power c, into dynamic viscosity, that is mu to the power d. So dimension for mu is ml to the power minus 1 t to the power minus 1 to the power d. Then equating the powers of m, l and d on both sides. So first let me start with equating the power of m. So on left hand side power of m, that is m to the power 1, that is equal to 1, and right hand side m to the power c and m to the power d. So 1 equal to c plus d. Then equating the power of L, on left hand side it is L to the power 1, so power is 1. On right hand side it is L to the power A, L to the power B, L to the power minus 3C and L to the power minus D. So we get expression as 1 equal to A plus B minus 3C minus D. Then equating the power of T, on left hand side it is minus 2, on right hand side it is minus B and minus d. So minus 2 equal to minus b minus d. So here there are two steps actually. We can follow, you can follow any step, like whichever you feel easy you can follow that. Let me go with first method here. There are 4 unknowns a, b, c and d, but equations are 3. So by equating powers of m, l and t, we got 3 expressions, but we have unknowns 4, a, b, c, d. So hence it is not possible to find the values of a, b, c and d, but 3 of them can be expressed in terms of fourth variable, which is most important. So our left out option is we can express a b c or b c d in terms of left out parameter, that is a, or other parameter b or in terms of c. So which is most important. So we have to consider the most important parameter and we have to express all other 3 parameters in terms of that parameter. Here viscosity is having a vital role and hence ABC are expressed in terms of D, which is the power to viscosity. So we can see the expression mu to the power D. So we can mu is very important, so we can express in terms of D. Otherwise we can see these expressions, 3 expressions, and we have to search for common term. So that is in power of m 1 equal to c plus d, and in power of L 1 equal to a plus b minus 3c minus d, and in power of t minus 2 equal to minus b minus d. As we all can see here, D is common term, or that's what I told, viscosity is important. So if we are not able to find out the important term, we can just go with second method. This is a second method. We can look into the expression and we can search for repeating term or same term in all three expressions. So from this observation we can conclude D is the common term for all three expressions. So I can express expression 1 C 1 equal to C plus D. So in terms of D as C equal to 1 minus D. Then equation 3 minus 2 equal to minus B minus D. So I can express B as B equal to 2 minus D. Then we can go with the second expression, that is A equal to 1 minus B plus 3C plus D. Now we have values of C and B, so we can substitute in place of C and D as 1 minus D and 2 minus D respectively. So A equal to 1 minus 2 plus D plus 3 minus 3D plus D. So that is equal to 2 minus D. So all three variables, that is or constants A, B, C, expressed in terms of fourth variable, that is D. So that is a power to viscosity. So that's a very important step here in Rayleigh method. We have three expression but 4 unknowns. So it is very difficult to solve. So we can go for elimination method, or that's what it is called as. We can look into the expression and we can search for common term, and we have to express all three variables in terms of fourth variable. So here in these expressions, D is a common term for all the expression. So we can express C in terms of D, then B in terms of D, and C in terms of D. So once we get values of C, B, A in terms of D, we can substitute back those values in equation 1. That equation 1 is F equal to K into D to the power A into V to the power B into rho to the power C into mu to the power D. So I get expression as F equal to K to the power K into D to the power 2 minus D, V to the power 2 minus D into rho to the power 1 minus D into mu to the power D. So all the exponents are expressed in terms of D. So I can simplify this expression as equal to F equal to K into D square, taking D square term out from D to the power 2 minus D, and into V square, taking V square from V to the power 2 minus D, into rho, taking rho from rho to the power 1 minus D. So K into D square, V square into rho into remaining term. So first, in second term it is D to the power minus D is remaining. In third term V to the power minus D is remaining. In fourth term rho to the power minus D is remaining, and last term anyhow it is mu to the power D. So clubbing together or taking together D terms together, D power terms together. So that is equal to K into D square V square rho into D to the power minus D into V to the power minus D into rho to the power minus D into mu to the power D. So that is equal to K into D square V square into rho into mu divided by dV rho to the power D, taking D power terms together. So mu, it has positive power, mu to the power D, so it stays in numerator, whereas D to the power minus D, V to the power minus D, rho to the power minus D, it has negative power. Those have negative power, so it goes to the denominator and becomes positive. So that is mu to the power D divided by D to the power D, V to the power D into rho to the power D. So we can take power common, that is D to D power. So it becomes mu divided by dV rho to the power D. So that is equal to K into D square V square rho into function of mu divided by dV rho. So we can just neglect the power. So it is already it is a function of, when it is a function of mu divided by dV rho, then it should be a function of mu divided by dV into rho. So there's a thing here, you can just express as a function of some parameter phi. So K into D square V square rho into some function, I neglected that power, mu divided by dV rho. So this is a solution for second problem. It's a very simple problem, but here the problem is we have 3 equation, 4 unknowns. So we have to express 3 parameter in terms of 4th parameter. So here it is D. So viscosity is important. So we can go with that thing also. Otherwise you can just look into the expression and you can search for common term. So then substitute that values of A, B, C in terms of D in equation 1, and we can get a final expression, and you have to express in terms of some function. So here the final expression for drag force, that becomes k into d square v square rho function of mu divided by dv rho. So this is a solution for second problem. So I'll come up with some more problems in next video. Thank you.